In this video, we want to discuss the Python bitwise operators. The first one will be bitwise AND, with the ampersand as the symbol for the operator. And you can see that anything with a 0 gives a 0, and the only way we can get a 1 is if we AND a 1 and a 1. Then the next one would be the bitwise OR operator. And here, that's the vertical bar, and here we get a 1 if either operator is 1, and the only way we can get a 0 is if both operands are 0. And then the complement operator, denoted by the tilde, you see that if we complement a 4-bit string, that we do it bit by bit, and so the complement of 0 is 1, and the complement of 1 is 0. And now we're going to consider a 4-bit number, and we're going to consider the 16 different 4-bit numbers that we have right here, because you see we're denoted them by 0 or 1. And so here is 4 bits, here's the decimal equivalent, and here is the hexadecimal equivalent. And in the hexadecimal equivalent, at 10 we go to A, then B, C, D, and F. We now look at the bitwise complement operators, where we look at X ranging from 0, 0, 0 to 1, 1, 1, 1. And this would be the complement of X. And then this answer would be in decimal. And then this answer will be in hexadecimal. And so we see the number, the complement, in decimal, the number, the complement, and in hexadecimal, the number and the complement. So just as another example, suppose we consider 6, which is 0, 1, 1, 0. The complement is the 1s and the 0s change places. And then 6 and 19 add up to 15. And then here will be 6 and 9 again in hexadecimal. And that won't be different than the decimal until we get to the number 10. Looking at bitwise and look at the 16 possibilities from 0, 0, 0, 0 to 1, 1, 1, 1. And here is the AND operator, and it's done a bit at a time. And along the diagonal, I show the answer of a number ANDed with itself, and we see that we get itself. And so we have that property that any number ANDed with the same number gives the number itself. And you can see that right here, 1, 1, 1, 0, 0, and here we AND it with 1, 0, 0, 1, and we get a 1, and all the rest are zeros. We do it bit by bit. For the OR operator, it's a similar situation, but in this case, we will get a 1 if either one of the operands is a 1. And so we can see that if we OR this with something else, say this one right here, we just get the 0, 1, 1, 1, because that when left operand with the 0, 1 won't change anything. And again, we have the diagonal, and if you look down the diagonal, you will see that any 4-bit number ANDed with itself gives itself.